Hello, this video is for IXL Activity A1.J.4. It is titled Solve Two-Step Linear Equations. The three-character code for this activity is Quebec Alpha Kilo. So in this case, we've done one-step equations. Now we're doing two-step equations. In the one-step equation, we only had to take one step before we got to a solution. We used inverse operations. We undid addition with subtraction and undid subtraction with addition. We undid multiplication with division, and we undid division with multiplication. This time we're going to have two steps before we get to the solution, and we're still going to go ahead and deal with inverse operations. We're going to undo addition with subtraction and multiplication with division. But first, before we can do the one-step equation, we have to deal with the two-step equation. And you might be saying, well, wait a second, what do you mean by that? So let's go ahead and look at that. I'm going to start off with 6 plus the 3f equals 15. Now, if we took away this 6 over here, we just saw 3f plus 15, that'd be a one-step equation, right? We need to go ahead and divide both sides by 3. But before we can isolate the variable of f that's being multiplied times 3, we have to first go ahead and deal with the 6 that we have here. So let's go ahead and work our way down to that. So we have this positive 6 here, so let's go ahead and subtract 6. And what we do to one side, we're going to do to the other. The 6's are going to cancel each other, leaving with just 3f on the left. And 15 minus 6 is 9. Now I'm at a one-step equation. I did one step. Now I have a second step to do, thus the title, two-step linear equations. So let's go ahead and divide both sides by the number we wish to get rid of. 3 is being multiplied times f. So we're going to divide. Every fraction is a division problem. We're going to divide by the number we wish to get rid of, which in this case is 3. And what we do to one side, we do to the other. The 3's will cancel each other, leaving me with f. And 9 divided by 3 is 3. So f equals 3. Now you could always check your answer. What if you plugged a 3 in here? 3 times 3 is 9. 6 plus 9 equals 15. Indeed, that is the correct answer. So f equals 3. So especially whenever you get up into the 80s and the 90s and you're risking more, possible in IXL activity there, be sure to go ahead and check your answers. It's good to do it all the time. So I have 4q plus 2 equals 18. So before I can get to the 4q part, I have to deal with this plus 2. Well, plus 2, well, the opposite of 2 is negative 2, so we're going to subtract 2. What we do to one side, we're going to do to the other. These 2's are going to cancel each other out, leaving us with 4q on the left, and 18 minus 2 is 16. I now have a one-step equation. 4 is tied to the q through multiplication. I'm going to go ahead and divide. Remember, fractions are division problems. I'm going to divide by the very number I wish to get rid of, which is 4. And what I do to one side, I'm going to do to the other. 4 is going to cancel each other, leave me with q, and 16 divided by 4 is 4. Therefore, q equals 4. Next example, we have 2v minus 3 equals 3. So before I can deal with the v that's tied to the 2, I have to deal with this minus 3 here. Well, the opposite of minus 3 is positive 3, so I'm going to add 3. What I do to one side, I'm going to do to the other. 3's will cancel each other, leave me with 2v on the left, and 3 plus 3 is 6. I now want to go ahead and use division to undo the multiplication. Divide by the very number I wish to get rid of, which is 2, and what I do to one side, I'm going to do to the other. 2's cancel each other, leave me with v on the left, and 6 divided by 2 is 3. 3u plus 2 equals 8. So let's rewrite our problem. 3u plus 2 equals 8. So before I deal with the u tied to the 3 through multiplication, I have to deal with this plus 2. The opposite of 2 is negative 2. So what I do to one side, I do to the other. The 2's are going to cancel each other, leave me with 3u on the left. 8 minus 2 is 6. Now let's go ahead and undo the multiplication here with division. Let's divide by the very number we wish to get rid of. The 3's are going to cancel each other, leave me with just u, and 6 divided by 3 is 2. I guess I could put my answers in there. 3 and 2. Solve for D. Oh, here's an interesting one. We haven't seen something like this yet, at least not in this activity today. So d over 3 minus 1 equals 1. So before we deal with the d being divided by 3, we need to deal with the negative 1. So let's go ahead and add 1. And what we do to one side, we're going to do to the other. So the 1's will cancel each other, leaving me with d over 3. And 1 plus 1 equals 2. Best way to get rid of a fraction, multiply by the denominator. So I'll multiply both sides by 2. And I guess over here, since that's a fraction, I'll make this a fraction as well. And 2 times 2. And nope, 3. Right? So we want to multiply by 3, not 2. All right, so the 3's will cancel each other, right? We'd end up with just d. So notice that whenever we multiply by the denominator, we get whatever the numerator was. And 2 times 3 is 6, and looky there, we're at our solution of d equals 6. We are at z over 3 plus negative 3 equals negative 7. So to get rid of the negative 3, I need to add 3. What I do to one side, I'm going to do to the other. The 3's cancel each other, leaving me with z over 3 on the left. And negative 7 plus 3, well, we're adding a negative and a positive number together, so we're actually going to subtract. The difference between 7 and 3 is 4. And the negative 7 has a greater absolute value than the positive 3. So we're going to use the sign that matches the negative 7. So that 4 would be a negative 4. Now let's get rid of the fraction by multiplying times the denominator. What we do to one side, we do to the other. The 3's will cancel each other, leave me with just z on the left, and then negative 4 times 3. Negative times positive is negative. 4 times 3 is 12. Therefore, z equals negative 12. Here we have 3 equals k over 8 minus 3. So 3 equals k over 8 minus 3. So we got to deal with this negative 3 here. So let's add 3. And what we do to one side, we're going to do to the other. Those 3's are going to cancel each other. And on the right, we're going to be left with just k over 8. And 3 plus 3 is 6. Now let's multiply by the denominator. What we do to one side, we do to the other. These 8's will cancel each other, leave me with k. And 8 times 6 is 48. So k equals 48. N over 4 plus 9 equals 12. So n over 4 plus 9 equals 12. Well, positive 9, so let's subtract 9. What we do to one side, we're going to do to the other. These 9's are going to cancel each other, leave me with just n over 4 on the right. And 12 minus 9 is positive 3. So I have n over 4 equals 3. One more step to go. We did the first step. Now let's do the second step. So I'll multiply by the denominator. What I do to one side, I do to the other. These 4's will cancel each other, leave me with n. And 3 times 4 is 12. This time we have a positive 12 for a solution. N equals 12. Now we're going to get into decimals, but the calculations might be a little more complicated, but the process is still the same. So let's go ahead and do z over 2 plus negative 2.2 equals negative 4.2. And so this is a negative 2.2, so let's add 2.2. And what we do to one side, we're going to do to the other. And then these are going to cancel each other out, leave me with just z over 2 on the left. And then negative 4 plus negative 4.2, right? Negative 4.2, and I'm going to add to that 2.2, and that's going to give me a result of negative 2. Now let's go ahead and multiply both sides by the denominator of 2. Times 2 times 2. 2's cancel each other, leave me with z, and negative times positive is negative. 2 times 2 is 4, therefore z equals negative 4. And let's see, does that make sense, negative 4? Because negative 4 divided by 2 is going to be negative 2. And then negative 2 plus negative 2.2 would be negative 4.2. Yep, that's it. On the next one, I have negative 4z plus negative 8.6 equals 9.52. So let's deal with the negative 8.6, and let's add 8.6. And what we do to one side, we're going to do to the other. So the 8.6 is going to cancel each other out, leaving me with a negative 4z equals, and then 9.52. And we're going to add to that 8.6 is going to give us 18.12. So 18.12. Now I need to divide by the number I wish to get rid of, which is negative 4. And what I do to one side, I'm going to do to the other. The negative 4's cancel each other, leave me with z. And then whenever I divide 18.12, divide that by negative 4, that's going to give me a value of negative 4.53. So our solution is negative 4.53. Solve for r. So I have 2 minus 3r equals negative 4. So let's deal with, I know why I put this one in here, because the negative sign's in front of the 3. So this is a positive 2 over here. So I want to, subtract 2, right? Let's go ahead and do that. So I want to go ahead and do minus 2. So I get rid of the positive 2. And what I do to one side, I do to the other. So I'm actually adding a negative 2 to each side, right? So the 2's going to cancel each other, leave me with negative 3r. Be careful not to just bring down 3r. You got to bring down to negative 3 right there. So bring that down there. And then negative 4 plus negative 2 is going to get even more negative and be negative 6. So now we want to divide by the number we wish to get rid of, which is negative 3. And what we do to one side, we're going to do to the other. The negative 3's cancel each other, leave me with r. And negative divided by negative is positive. 6 divided by 3 is 2. So r equals 2. On the next one, I have negative 17.06 equals negative 3.86 plus negative 4m. Probably putting these in because we're going to be divided by these negatives. So let's see. This is a negative 3.86, so let's add 3.86 to each side. So I'm going to add 3.86 to each side. The 3.6s are the 3.86s on the right are going to cancel each other, leave me with the negative 4m. And now I need to do negative 17.06, and I'm going to add to that 3.86, and that's going to give me a value of negative 13.2. Now I need to divide by the number I wish to get rid of, which is negative 4, and what I do to one side, I'm going to do to the other. The negative 4's cancel each other, leave me with m on the right, and then negative 13.2 divided by a negative 4 is going to give me a positive 3.3. So my solution is 3.3. And my last example here, the reason I probably put this one in is it's a minus a negative. So whenever I rewrite this, I would first approach this problem by doing the 0.94, and then instead of minus a negative, I'm going to do plus a positive and put that over to plus b equals negative 1.27. So all I did is I changed the sign here from subtraction to addition and then took the opposite of the number that follows. Okay, so minus a negative is the same as plus a positive. So now I can go ahead and approach this from, I would need to get rid of the 0.94, so let's subtract 0.94. And what I do to one side, I do to the other, so I'm actually adding a negative 0.94. So I want to do negative 1.27, and I want to add to that a negative 0.94, and that's going to give me a result of negative 2.21. And I should expect it to go to something even more negative, right? Because negative plus negative is going to get even more negative. The 0.94 is going to cancel each other over there and bring down the b, and wow, I'm done. That was like a one-step equation. I guess the first step was to do the minus and negative is the same as plus a positive. So I guess I kind of did 2 steps on that one there. But my final solution for this problem is negative 2.21. All right, so those are all of my examples for IXL A1.J.4 Solve two-step linear equations. Good luck with your activity.